All right, let's go ahead and get started. Good afternoon. Really? Is this thing on? I said, good afternoon. All right, thank you very much. Awesome. Well, it's great to be here. We're going to be talking about Exchange 2013, high availability and site resilience. And there's also some storage-related content in here as well. How many of you are running 2013 today? All right, how many of you are running 2010? 2007? All right, how many of you are doing CCR in 2007? And how many of you have a DAG in 2010? Any 2013 DAGs here? Any 2013 DAGs running on Windows Server 2012? Awesome, fantastic, great. So as I mentioned, the agenda is fairly straightforward. We're going to talk about some of the storage innovations that we've introduced in Exchange 2013. We'll also talk about some of the high availability innovations and some of the site resilience innovations that we've done, things that make Exchange 2013 a bit better in terms of the experience around those areas over Exchange 2010 and its predecessors. And we'll also talk briefly at the end of some changes in this area that are coming in Cumulative Update 2, which is the update that we will be releasing next. Just before we start the questions that will be inevitable, I don't have a release date for CU2, so please don't ask. I couldn't tell you anyway. All right, so let's start by looking behind the curtains as we delve into the storage innovations that we've introduced in Exchange 2013. A couple things I want to mention first, though. A lot of what you're going to hear me talk about are innovations that we've introduced into the on-premises product that were actually born out of us running the product in a large-scale service like Office 365 and Exchange Online. So there's a lot of learnings that are coming from our experience in the service that are making its way into the on-premises product and benefiting those of you who are running it. The other point I want to make is particularly around the storage innovations. They are largely targeted towards environments that are using JBOD as the storage configuration option. If you're not familiar, JBOD is an acronym, JBOD. It means just a bunch of disks. It's a storage configuration that doesn't use RAID, so sometimes we call that RAIDless. Now, even though the innovations that I'm about to discuss are largely targeted towards JBOD environments, they are supported and usable on all supported storage that we have for Exchange. So even if you're running, DAS, SAN, RAID, RAIDless, all of these things are still well within your reach, and you can take advantage of any of them. But you will see, as we talk about some of the challenges and innovations that we've introduced, that a lot of this is really targeted towards those large-scale JBOD environments. So what are some of the challenges we have around storage? Well, there's a few. Let's start with the disks themselves. One of the challenges we have around disks is dealing with the fact that they're getting larger, but they're not getting faster. So when you're talking about platter-style disks, like a SATA or a SAS disk, we're really topped out at about 15,000 RPM. But at the same time, the disks are getting larger, and from an Exchange perspective, that does present some unique challenges, particularly since from the Exchange product group's perspective, we are very vigorous about making sure that Exchange customers get to fully leverage all of the hardware that they bought. So we had to come up with innovations to use these large hard drives very efficiently. And so we'll talk about that in a bit. Another challenge is the databases. Just as it was with the case with every version of Exchange, your database sizes need to be manageable. The size itself, in terms of manageability, will vary from platform to platform, but they still have to be kept to a reasonable size. What do we mean by reasonable? Well, if you're not replicating your databases in a day, we would recommend not growing them larger than 200 gigabytes. And that's simply because if you're not replicating them, you're using old-style backup and restore to protect your data. And 200 gigabytes is a lot of data to have to back up and restore if needed. If you are replicating in a DAG, then our recommended maximum size would be 2 terabytes per database, much, much larger. That is, by the way, the same recommended size limits we had in Exchange 2010. We think 2 terabytes is a pretty good number because particularly in a replicated environment, both from a reseed operation and some of the other management operations, that is a large data set, but it's operationally manageable. It's still a reasonable size even at 2 terabytes worth of data. And then there's some other challenges as well. Again, particularly in a JBOD environment, if we lose a disk, for example, well, we don't have RAID, which means if we lose a disk, all the data that was on that disk is lost with it. So that's one challenge. And of course, the data that we're talking about is an Exchange database and its logs and the content index. And of course, when that data is lost and a new disk is put in its place, that disk has to be reseeded with that data. And of course, the reseed operations also have to be fast and reliable as well. Now, there's a couple other interesting nuances about the high availability platform in Exchange 2010 that ended up being challenges. And those surround the lagged database copy. How many of you have deployed lagged copies in 2010 or 2013? Okay, so in 2010, in particular, the lag copy has two challenges associated with it. One is that it kind of messes with your design. A lag copy has asymmetric storage requirements. In other words, if you're not familiar with it, a lag copy is a passive database copy where the log files, once they're over there, they're not replayed right away into the database. There's a lag time for the replay to occur up to 14 days. And so because the logs can build up on a lag copy, that means you have to plan your storage design slightly unique around the lag copy to accommodate for that. The other challenge, though, is just when you're using the lag copy. Lag copies in Exchange 2010, they require manual care. So if you're in a situation where you've got low disk space or reduced redundancy because you've lost some passive copies, or you're in a situation where you need page patching because there's database corruption that needs to be corrected. Those aren't things that can be done automatically in Exchange 2010 with a lag database copy. So the lag copy requiring all of this manual care was another specific area that we wanted to address. So in addressing these solutions, we came up with some storage innovations, and that's what I'm going to be talking to you about in this first part of the presentation. We're going to talk about a feature called multiple databases per volume. We'll talk about a feature called auto reseed. We'll also talk about some of the self-recovery behaviors that Exchange has built in to help protect itself from storage-related failures. And then we'll talk about some innovations we've done around lag copies as well. But let's start with the first one, multiple databases per volume. And what I find most interesting about this particular feature, it is literally the exact opposite of what we would have told you to do, say, for instance, 5 or 10 years ago with your Exchange databases. For those of you who've been doing Exchange for a while, you know when we started out, even in RAID environments, it was always for resiliency and recovery reasons. You would have your databases on one RAID volume and your log files on another RAID volume. And that was great because that was the technology that we had at the time, and that was how we could protect that data at that time. And then we moved into 2007 and 2010, and with the built-in data replication, then it sort of became a question as to whether or not you really need RAID. Because when you think about it, RAID is really just another copy of your data at the hardware level. And if you've got the application already making copies of your data for you at the application level, then you might not need the complexity that comes with RAID. You might not need the expense, the technology, and you might not need the protection. And in fact, we've been running since day one, whether it's been live at EDU or Exchange Online or Office 365, we run in all JBOD. We don't use any RAID at all. It's all JBOD, which in the Exchange 2010 paradigm is one database plus its log stream and its content index files on one single disk that's not protected by RAID. Well, we're extending that now by saying multiple databases plus their log stream and their content indexes all on the same single volume that's been formatted with a single partition, and you just have separate directory structures for all of your databases. So, what do I mean by that? Well, this is one example illustrating multiple databases per volume. And I say this is one example because not everybody is going to need 4 copies or 4 servers and so forth. This is just showing you one example. My example happens to be a 4-member DAG, 4 servers in my DAG. I do have 4 databases. DB1, 2, 3, and 4. And I've got 4 copies of each database, and I happen to have 4 copies per volume as well, 4 databases per volume. Now, in my, excuse me, in my example, you can see here, I've got a mixture of database types. It's active database in green, passive databases in blue, lag database copies in yellow. to do multiple databases per volume, you do not need lag copies. This is just, again, one of many different variations you can configure to show you that a lag copy can be part of this symmetry as well. Here I'm just illustrating that I've got one lag copy of each database that is spread evenly across my servers. In fact, there's a lot of symmetry in particular built into this design, and that was on purpose. For instance, we want the same neighbors on all of the servers because it gives us a building block model from which we can scale up to almost any size that we need to scale. And again, you don't need the lag copy there. I'm just illustrating it here. But let's back up a bit and see why multiple databases per volume is actually a great solution for today. So think about it. The single database per volume paradigm that you have today. And again, this is a JBOD. So each one of these gray cylinders that you see right here is actually just a single disk. It could be a single SATA disk. It could be a single SAS disk. The point is, it's one disk that's formatted as a single volume, and it's not protected by RAID. Which means if the disk on server 1 dies, well, that disk is dead now. You saw DB1. I'll back it up here. Watch, DB1 is green, active on server 1. When that disk dies, because of the high availability, server 2 inherits the active copy of DB1 and keeps things going. But now it's up to the administrator to go and replace that disk. And when they're done replacing the disk, then they need to reseed the disk with the data to reestablish redundancy for the missing database copy. Now, herein lies the challenge. We have these two competing size limits, if you will. You've got the recommended size limit that we have for our Exchange databases, which again in a DAG would be 2 terabytes per database. But if you look at the hard drives that are available today, and more importantly, the types of drives that will be available later this year or this time next year, those drives are going to be 4 terabytes, 6 terabytes. Maybe by this time next year, you might see an 8 terabyte drive in SATA form factor. And so if you just have a single 2 terabyte database that's on an 8 terabyte drive, well, then you've wasted 6 terabytes worth of disk space, and we don't want you to do that. Of course, the other thing we wouldn't want you to do is grow your database beyond 2 terabytes so that you can use all that space. Because here's why. Again, looking at the single database per volume paradigm, if I have to do a reseed operation, that's going to be taking data from, in this case, the active copy on server 2, and it's going to be pumping it as fast as it can over to server 1 to reestablish redundancy. So let's just compare the difference in times between 2 terabytes worth of data and 8 terabytes worth of data. So if that's a database that I've kept at our maximum size limits of 2 terabytes, and the 2 terabytes includes the log stream and the content index, that's going to take me about 23 hours to do that seeding operation. And that's not bad. Less than a day, I can reestablish redundancy of a large 2 terabyte data set. That's not bad at all. But if that's a very large drive and that's a very large database, say, for instance, it's an 8 terabyte database, well, that's going to take about 93 hours to reseed that operation. Okay? That is operationally untenable. If it takes you 93 hours to restore redundancy for one of your database copies, that potentially puts you in a very bad spot. And so the challenge is now multiple databases per volume, or the solution rather is multiple databases per volume, because the same scenario, we lose that disk, the disk dies, in this case it takes out 4 databases with it, 4 different copies, and you can see the copies fail over and become active somewhere else, and now again we have to reseed that. So if these are small databases, if you've got 2 terabyte drives and you've got 4 500 gigabyte databases, it might only take you maybe 9.5 hours to do that reseed operation. But if you're filling up the disk and you've got, say, for instance, 4 2 terabyte drives for a total of 8 terabytes, it's only going to take you about 39 hours to reseed that amount of data. Okay? So if you're wondering why it's so much faster in this paradigm, think of it like this. In the previous paradigm, with just a single server, we are what we would consider to be source-bound. Okay? We are sending the data onto that new disk from one source and only one source, in this case, server 2. The source in a seeding operation in Exchange, whether it's 2010 or 2013, will always be the bottleneck. It will always be the slowest part. It will never be able to keep up with the network or the target drive. So the source is always going to be the slowest point. So this is one challenge here. We are source-bound because we're serving one database or coming from one source here. The other challenge is how the way the data is laid out. If it's a single database and it's 8 terabytes, that is one 8 terabyte stream that has to come from that source. Okay? And not to mention the fact that in a seeding operation, if it gets interrupted, you get to start back from the beginning. So even if you could get all 8 terabytes to go over, there's the question of whether or not you could do that reliably. But in the multiple database paradigm, when you're doing a seeding operation, not only are you coming from multiple sources, as you can see here, but the data is chunked up into 2 terabyte data sets, if you will, that we just happen to call a database. And so that means you get a much faster overall seeding time. So think of it as the difference between seeding a single 8 terabyte blob of data versus 8 terabytes of data carved into 4 chunks. That's why it's faster. Carving it into 4 chunks like this, we're able to seed from multiple sources, and we're able to dramatically reduce the amount of time it takes to fill that disk back up with the amount of data that you have there. So this is where multiple databases per volume comes in. We did a substantial amount of work in Exchange 2010 and 2013 to reduce the amount of IOPS that are required, in particular for the passive database copy. And so overall, if you look at our IOP reduction between 2010 and 2013, it's about a 33% reduction in IOPS. It can be higher if you're talking about IOPS in other places like search and so forth, but we're really just focusing on database copy IOPS right now. So because we were able to reduce database copy IOPS, we're able to comfortably support multiple databases on the same disk volume, even a low-end SATA or SAS disks. You won't choke out the volume in this configuration. So again, this is showing you 4. You could do it with 2. You could do it with 3, with 5, whatever meets your needs. And what's really beautiful about some of the work that we've done in the new server role requirements calculator for 2013 is we anticipate this needs, and we will factor this into the design that we will output in the calculator for you as well. So we make it very easy to figure out the symmetry that you need and where the databases need to go by using our tools. So the requirements are pretty simple and straightforward. That one disk has to be a single partition, a single volume. And obviously underneath that single volume, you will have separate directory structures for each of your databases. But that's all you need to do. It's just one partition, and then place the databases on there. We do have some recommendations. We do recommend that you build symmetry, that building block symmetry I talked about earlier, into the design. And you can simply do that by ensuring that the number of database copies that you have be equal to the number of databases per volume that you deploy. Okay, that gives you that nice symmetry. And it also means that you'll have the same neighbors on all servers, as you saw in my example. That makes things super easy from a management standpoint, because all of your servers basically end up being clones of one another with just different differentiation between where the active and passive databases are. So let's talk about another feature, auto reseed. And again, this is one of those things that was born out of our experience in the service. As you might imagine, a service like Office 365, at the scale at which it is running today, we see all kinds of failures happening all the time. But by and large, the most common failure we see by a wide margin will be a disk failure. And as I mentioned, we're all JBOD in that environment. And historically, with Exchange 2010 in a JBOD environment in Office 365, if we had a problem, and every day there would be disks failing, it's not a reflection of the quality of the disks. It's a reflection specifically of the scale at which we are operating. When you figure your annual failure rate for disks, and if you're not sure what yours are, ask your storage vendor, we are well within the annual failure rate for the disks that we buy. But because of the scale that we are at, we see failed disks all the time. So in the Exchange 2010 paradigm, when this happened, as you saw, because we're JBOD, it would take out the databases. And when that would happen, we would have to dispatch an operator. It's what we call an administrator in the service. And the operator would have to go and pull the dead disk, put in a new disk, initialize it, and then kick off a seeding operation, and then babysit the seeding operation until it was finished. Now, any time in the service where we have to dispatch an operator to do any sort of manual tasks, that costs money. Okay? People are not free. We have to pay people to do that, and that costs money. And at the scale we're at, if we had to keep paying people just to go replace failed disks and do reseeding operations, we wouldn't be able to offer the service at the low price that we're able to offer it. So we had to come up with a mechanism to offset those costs. So again, thinking about the challenges that we were facing, because we're in a JBOD environment, any disk failure means a database goes out with it. And that also means that a new disk needs to be put in and initialized, and then a reseeding operation has to take place. So we have this innovation, and it's called auto reseed. And so basically the way it works is I have these two volumes of storage. So in the middle here, that's my Exchange server that's in use, and it has these pools of storage, if you will. I've got a bunch of disks that have databases on them, and then down at the bottom, I've got some spare disks. These are extra empty disks that have just been put in the system, formatted and initialized, and just left there as spares. And the way it works is when you lose one of those disks and it takes out the database, when auto reseed is properly configured, it will grab one of those spare drives and automatically remap it into a specific mount point structure. I'll show you what that looks like in a minute. But after that remapping is done, it will automatically invoke an automatic reseed operation from whatever database copy just became the active copy of that database. And that way, it will happen automatically. Sure, the administrator has to set up the spares ahead of time, but once that's done, the system takes it from there. It's all completely automatic. And then at that point, the administrator would go and pull the dead disk and possibly replace it with another spare, but that is a very quick type of operation that just takes a couple minutes, and it's not very expensive at all. All right, so let's dig a little deeper into what auto reseed will actually do. So it's a workflow that gets kicked off that does all of these things for you. So once it's set up properly, it's pretty much self-sustaining at that point. And again, I'll show you how to set it up in a minute. But basically what it does is it's regularly, periodically scanning all of your database copies, and it's looking for any database copy that is in a failed and suspended state. That is, in fact, the only workflow requirement for auto reseed, that we have a database copy that is in a failed and suspended state for at least 15 minutes. And I'll walk you through all the steps deeper, but for now, just know that we're looking for something in a failed and suspended state. If we find it, we'll run through some prerequisite checks. We'll, for instance, check internally and make sure auto reseed's been configured properly, make sure there are spare disks available, et cetera, et cetera. And then assuming there is, we'll go ahead and grab one of those spares, we'll allocate it and map it into the appropriate file structure. Then we will start the seeding operation, again, automatically in the background. And once the seed is completed, auto reseed will verify that it's healthy, that the passive copy's been reseeded and is now a viable, healthy copy. And then at that point, it's up to the administrator to just replace the failed disk. It's a very, very simple process. Let's dig a little deeper here. So when auto reseed detects a copy in a failed and suspended state, the first thing it's going to do is it's actually going to try and bring it out of that state. It will run an internal suspend and resume operation. We do that because we found, again, at scale in the service, we found a couple corner cases where we would resume a database copy and it would not come out of a suspended state. And after being in a suspended state for a while, it would go into failed and suspended. So we put in this little tickle. We'll try to suspend and resume it a few times just to see if it might be in that flaky state. If it doesn't come out of failed and suspended, then we'll continue with the next one. And that will be try to assign a spare volume. And we'll try that a few times as well. You'll see there's a few retries built into several of these operations, in some cases because we recognize that the administrator might not be able to fix the problem right away. Perhaps they did have spare disks in there originally, but now they've run out of spares and they need to go get another spare. So we will put in some delays in there to give them time to do those sorts of things. So we'll try to do the spare assignment up to 5 times with 1 hour sleeps in between. So there's about a 5.5 hour period where we'll sort of wait and see how things are. And then if we can grab a spare, then we'll do an in-place seed. It's very similar to the update mailbox database copy command that you would run, except it's happening programmatically behind the scenes with a parameter that allows it to do asynchronously and exit the task. And then if we've exhausted all retries, we stop the workflow, and then we wait, and then we'll start it up again. The only other thing that we'll wait for is if we do find data present on the drive. because that might indicate that there was another seeding operation that perhaps the administrator tried ahead of time, and they might not want auto reseed to overwrite that. So there is a couple day waiting period that we wait when we find data there. If the data is still there after that waiting period, though, we will go ahead and wipe it out and do the full reseed operation. Now, one other thing to mention is it says up there, detect a copy in a failed and suspended state. Auto reseed works great with multiple databases for volume. But for auto reseed to automatically reseed in a multi-database per volume, all of the database copies on that volume have to be in a failed and suspended state. So if you've got 4 databases on that volume, 3 are failed and suspended, 1 is healthy, auto reseed will not do anything for you. It will only be invoked if all copies on that volume are in a failed and suspended state. And basically, that means your disk is dead, by the way. It's basically going to be a dead disk operation, meaning the operating system can't see it anymore, or Exchange cannot read from or write to it anymore. So it really will be a dead disk. All right, so there are some prerequisites for auto reseed. Obviously, you can't have things be reseed blocked. The logs and databases have to be on the same volume. That's a requirement there. If there's multiple copies, all copies have to be in failed and suspended on that volume. And then we do have a limit on the number of in-place concurrent seeds that we can do. It's quite large, though. We'll do up to 10 concurrent seeds. I would be really shocked if there were any customers who ever did 10 databases per volume. That is a ridiculous number of databases per volume, and I can't imagine anybody ever going that large. The reason we have it to 10 in code is so that we can exercise the code at a much greater scale in our own test environments than you would ever do in your own production environment. So we do have some limits there, but generally they're not limits that you're going to run into in any practical sense. All right, so let's talk about configuring auto reseed. Now, you can take an existing 2013 DAG and you can kind of retrofit it for auto reseed, but to do that requires you to basically take everything down, move everything around, and it's going to be a big pain in the butt to do that. So instead, what we typically recommend is customers who want to deploy auto reseed, they configure the DAG from the beginning with auto reseed in mind. And so those are the steps I'm going to run you through now. So the first thing would be to take your storage subsystem and configure it the way you want. So that would be including the disks that you want to store data on and the spare disks. Now, in my earlier example, you saw that there were 3 spare disks. The number of spare disks that you have in each of your servers is completely up to you. We originally had 3 in the service. We've moved down to 2 now. Because we think 2 is really all we need at any given time. And so all of our servers in the service have, at any given time, 2 available spare disks to them. Obviously, you need at least 1, but you don't need to go 3. 2 should be sufficient for most of your needs as well. So you'll configure the storage subsystem, including your spare disks, and then you'll create the DAG, and the servers whose storage you just configured, you will add them to the DAG. It's very similar to what you would do before. And then you'd create a directory and mount point structure, which I'll show you in a minute. This is new, and this is hard-coded into Exchange, so you have to do it exactly the way I'm going to show you. Then you'll configure the DAG, and there's 3 new DAG properties that you have to configure for auto reseed. And then, just like you would with any DAG, you'll create your mailbox databases and your database copies. All right, let's look a little bit deeper at that structure now. And this is going to take a few seconds to build. So what we're really doing with auto reseed is we have to tell Exchange 2 things. We have to tell Exchange where all the databases are and where all your spare disks are. Okay, or basically where all your storage is. And both of these things are in the same place. Your databases are on the storage, and we need to tell Exchange where both of these things are. But the way we do it is kind of clever, I don't mind saying. What we're actually doing is we are just creating duplicate mount points that point to the same location. So here, for example, let me use my mouse to illustrate some things. You see, let's start at the top right here, this circle with that white line in there. Now, we talked about the need for the disk to be a single volume. And in fact, that is a requirement for auto reseed as well. So what you're seeing, that circle with the slash in it, that is the root of that volume. Okay, so that would be like C:\\, if you will. And then underneath that root are 2 other directories. One which has a long name by default of Exchange volume, and another one which has a long name by default of Exchange databases. Those are the default names. They were too long to fit in the bubbles, so I didn't put them in the bubbles. Instead, I'm illustrating the fact that you can create custom directories instead. You don't have to use our default ones. You can do what I did, exch vols for the volumes, which is all your storage, and exch dbs for your databases. And those are the two mount point primary folders under which everything is mounted. So below that, you can see, for example, under Exchange volumes. Again, this is where the storage is. You can see 3 volumes, 1, 2, and 3. Volume 1, as you can see, has MDB1 and these two MDB1.db and MDB1.log coming off of it. Volume 2 should have the same thing, but there wasn't enough room to get all of that on there. But Volume 2 has basically the same thing for MDB2, and Volume 3 has nothing on it. That is my spare in this configuration. And the reason you see these yellow lines between the green MDB1 cylinder, which is up here, I'm pointing it out in case people are colorblind, and this green circle right here is because they're the same exact thing. It is literally the same exact folder that is just mounted under 2 different mount points, one for volumes, one for databases, which means this directory here, which is where the database is located, and this directory here, which is where the logs are located, is the same as this one and this one, respectively, as well. We are just surfacing it 2 different ways because this is how we tell Exchange where all the moving parts are. Now, once you have that, there's a couple other parameters that you need to configure. So one is the autodag volumes root folder path. That's going to point to wherever your volumes are. In my case, exch vols. That is one of the new DAG properties that you'll configure. Another one is autodag databases root folder path. That's where you tell the DAG where all your databases are. Again, Exchange DBs in my example, or Exchange databases by default. And then the third parameter is that autodag database copies per volume. And that's where you tell auto-reseed how many database copies you have on each volume. That's important because remember, for auto-reseed to do its thing, all of the copies on the volume have to be failed and suspended. So that number has to be accurate. So if I were using that example that we started out with multiple databases per volume, I would configure that for a value of 4, because I've got 4 databases on each of my volumes. And then once all that stuff is configured, auto-reseed is configured properly. You do have to configure it this way, and in fact, it literally has to be database name.db and database name.log for those hard-coded folder names. We do that on purpose because in the service, we've hard-coded our deployment paths. Okay, and our deployment paths, I bet you can guess what they are. Exchange volumes and Exchange databases. So the auto-reseed construct and all the configuration elements are hard-coded into Exchange. So they are required. You have to follow our naming convention. You'll basically, if you use auto-reseed, you will be deploying your databases exactly how we deploy them in Office 365, because we've hard-coded the directory configuration information into Exchange, which means if you don't have your directory names right, if there's a typo in any of them, auto-reseed will not work. Okay, we'll assert, and you'll see an event in the event log saying auto-reseed failed prereq check, and it was not able to complete its task. So keep that in mind. If you're wondering where these weird directory structures come from, it's what we use in the service, and we've hard-coded it into Exchange. Now, there are some requirements. You do have to have, again, that single volume, but the more pressing requirement is what I just mentioned. You have to use our specific internally hard-coded directory naming structure. Otherwise, auto-reseed simply will not work for you. And that will not change, by the way. We are not backing off from that. Auto-reseed will always require that. We do recommend the same neighbors on all servers, just like multiple databases per volume. And we do also recommend that the number of database copies be equal to the number of databases per volume. Again, that's not really an auto-reseed thing. That's more of a symmetry building block thing. You can go to that URL. That's the step-by-step instructions for configuring auto-reseed. And I don't mind saying that they are very well vetted and bulletproof. And I would invite all of you to go try them out and prove me wrong. And if you happen to find some sort of problem with them, you can ping me directly, and I will fix it and publish it to the web that day. How's that? Except for Saturday and Sunday. And every other Tuesday. No. Now, in CU1, there's a bunch of fixes. Probably won't affect most of you because not very many customers actually deployed RTM. But we did find a few things that were wrong with auto reseed. For instance, it didn't always recognize when there were spare disks available, or it did recognize the spare disks, but it wouldn't use them, and so forth. So we did do a bit of work in CU1, and things are operating way, way more smoother than they were in RTM. The other thing I'll point out is there was also a management improvement that we did with Get Mailbox Database Copy Status. When you're using the multiple mount points for your databases, in Exchange 2010, we used to show you exactly where the database was. And so initially, we would now only show you the first mount point based on the order in which they were created. So now we'll actually show you the mount point under C Exchange volumes when you run that commandlet now. So that's another improvement that we did in CU1. Yes?
Once you've configured the auto receive with a specific number of spares, are you locked to that number?
No. No, auto reseed doesn't have any configuration information about the number of spares you actually have. All it cares about is whether a spare is available. So if you're low on a spare one day, or or you've had multiple failures, which might indicate maybe a controller problem, and you need extra spares, auto reseed will just be waiting there. It'll suspend its workflow until a spare is available for you. Some other seeding innovations that we did in CU1, I bring these up because these are particularly helpful in scripting operations. So with Update Mailbox Database Copy, which for those of you who aren't on 2010 or 2013, that is the PowerShell commandlet that you use to do a database reseed operation. And there's the new begin seed parameter that we added. So that basically takes that task now and it allows it to asynchronously exit, so you don't have to babysit the seeding operation. So if you like to script your seeding operations, you can do that now with CU1, whereas you basically couldn't do it before. I mean, you could, but as long as the seeding was going on, the process was still instantiated and it was still doing things. Now, with the begin seed parameter, it will just exit the task and begin the seed asynchronously in the background for you. And there are some other switches that we add there as well, largely for, again, scripting and automating reseed operations. All right. Let's talk about self-recovery from storage failures. Now, a lot of this is actually not entirely new to 2013. Some of these are behaviors we had in Exchange 2010 as well. And the challenge that we have here is, even though we're using about the simplest storage you could use for Exchange, still, we're dealing with storage controllers, and storage controllers are basically miniature PCs, and they can crash, they can hang, or there could be some other loss of vital system components, or some tragic operator error that occurs that puts the system in a bad state that will require it to recover from. Now, in Exchange 2010, we introduced a bunch of self-recovery behaviors to account for a variety of scenarios that we were encountering both in the service and in our dog food environments. So things like, for instance, ESC database hung I/O. Okay, that was one of the things we looked for. If we could not read from or write to the JET database or the mailbox database within about 240 seconds, Exchange would automatically self-correct by, in this case, forcibly rebooting the box. And the way in which we forcibly reboot the box, we terminate a process called win-init.exe. It's one of the core Windows system processes, and whenever that process is terminated, it bug checks or blue screens the box. And we do that on purpose because that is a fantastic way for us to programmatically trigger a server failover. As soon as the server bug checks, all the active databases fail over to one or more other surviving servers. So it's a great self-recovery mechanism. And of course, after the bug check is done, the system will come back up and hopefully be in a better state than before we faulted it. Similarly, the failure item channel heartbeat, that refers to the Crimson channel event log. If we can't read to, or write from that log within a 30-second period, that's bad for Exchange. We live and breathe in that Crimson channel area all day. In fact, that's how Active Manager finds out a lot of what it needs to do. ESC will log an event in there. Active Manager will read that event and then take action based on the event information. And if we can't do that stuff, Exchange cannot take care of itself. So that Crimson channel is super important for us. And if we can't use it in a 30-second period, we try to correct that problem, again, by forcibly rebooting the box. So all those behaviors are in Exchange 2010, and we've carried them forward into 2013. And 2013 adds some new behaviors as well. So like, for instance, a system bad state. That's where the system is in such a bad state that threads are no longer being scheduled by the processor, including managed code threads. So at that point, if we're in that state for about 302 seconds, we will again get ourselves out of it by forcibly rebooting that box. Now, anytime we do one of those forcible reboots, that does get logged in the event log, but the stop code also gets logged in a separate event in the system log because, after all, it is a critical Windows stop. And it's a very unique stop code. In fact, it'll have F4 in parentheses next to it every time. So you will automatically recognize the difference between a bug check caused by Exchange versus a bug check caused by some other mechanism, a bad driver or whatever. And in fact, when you see one of these bug checks, you can actually go searching for it, and that will take you right into the Exchange documentation where you'll find out that it was Exchange that just fixed this problem for you. Some other things that we do, in CU1, we added even more behaviors, and we're going to continue to add more as time goes on. So like, for instance, a bus reset. Anytime the storage bus resets, that's going to log event 129 in the event log. Our experience has shown that whenever a bus reset occurs, some sort of storage hang is going to result, requiring an operator to go hit the power button. So we decided to skip the operator. Whenever we see that bus reset, we know it's going to require some form of corrective action. We will go ahead and bug check the box and automatically correct that. The replication service endpoint's not responding. That might indicate that the service is down, or the service is running, but for some reason it's hung and no longer responding to RPC or TCP connections. If we encounter that, Exchange will self-correct by bug checking the box. And the last one, this cluster database hang, this is new. And it's actually only operating right now on Windows Server 2008 R2. Windows Server 2012 does not yet have this functionality. And the functionality is these extended cluster codes that we got the cluster team to put in to Windows failover clustering for us, but they've only added them to Windows 2008 right now. But with these extended cluster codes, we get more information about the state of the cluster database itself. And we've encountered a few scenarios in the service where Global Update Manager, which is what GUM means, the Global Update Manager inside the cluster was not able to do updates to a cluster database because that database was hung. And we really couldn't detect that until the cluster team added these extra codes in for us. So they're in there in 2008 R2. So if you're running Exchange 2013 on 2008 R2, you actually do get a benefit over Windows Server 2012. Eventually, 2012 will have those codes in there, and then that feature will work on that platform as well. But that is the one difference between R2 and 2012. All right. Now let's talk about some of the lag copy innovations there as well. So we already talked about some of the challenges, the fact that, well, activation is difficult. How many of you have actually ever activated a lag copy? Has anybody tried that yet? One person, and you don't even want to raise your hand the whole way. Yeah, that's how hard it is. Yeah, it's a very difficult and laborious process, particularly if you're doing log surgery and you're not replaying all the logs and you just need to find out where you're going to sever the log stream. And then lag copies require manual care. You know, one of the examples I gave earlier was low disk space. If you're running Exchange 2010 and you've got a lag database copy and the volume on which that copy is located is running very low on disk space, you have really low agility to get yourself out of that. Probably about the best you could do would be to throw away the content index and maybe get yourself a gigabyte worth of free disk space out of that. But that's still a manual operation that you have to do. And then lag copies, they can't be page patched. In Exchange 2010, we introduced this automatic page patching feature so that if we detected page corruption, like a JET negative 1018, negative 1019, 20, 21, 22, any of those, oh no, my database is messed up errors, we have the ability in 2010 to automatically fix up the corruption by grabbing a good page from a database that's not corrupt. But a lag copy, we can't do that in 2010 because the page that needs to be replaced might not even be replayed into the database at that point because it's a lag copy and the logs are being held back. So those are the challenges. In terms of the innovations, there's two primary innovations that we get. First is we gave lag copies sort of the ability to kind of care for themselves. And by that, I mean they can automatically start playing down their lag in response to one of those scenarios that I mentioned. So for instance, a low disk space scenario. Okay, so if you're below, say for instance, 20% free disk space on the volume where your lag copy is, the lag copy can automatically and will automatically start playing its log files so that they can be purged from the system once they're played, and it will do that until it's below that 20% free disk space threshold. Once it's within the threshold, it will stop replaying. So what that means is your lag copy, its actual point in time lag may be relative to the lag that you have configured because of one of these scenarios. Another one is page patching. If we detect that a lag copy is going to need to be page patched, we will bring it forward to the point at which it now has the page in the database, and once that page is in there, we will patch it and give it a non-corrupt database. We won't bring it any farther forward than that, but we will bring it forward up to the point of where the corruption is. And then the last one is when there's less than X number of healthy copies during a Y time period. And this is, by default, it's less than 3 copies in a 24-hour period. And this is a mechanism whereby basically if your lag copy becomes your only viable passive copy, it will automatically turn itself into a non-lag copy and become a passive copy that can be activated. Those are the primary care for themselves things that we've done. The other thing that we did is we've integrated the lag copy with a feature in Transport called Safety Net. Now, in Exchange 2010, we had this feature called Transport Dumpster. And Transport Dumpster was an area that was inside the mail queue file on every Hub Transport server, and it contained messages that were sent to a DAG environment, and the messages were held there either based on size or based on a time limit. And we held them there because anytime you have a failover of a database in Exchange 2010, it's what we call a lossy failover. Okay, that means we failed over to another server, but we lost some data. The overwhelming majority of data that would be lost, we get back by getting those messages out of the Transport Dumpster. Well, Transport Dumpster is gone in Exchange 2013. And in its place is a feature called Safety Net, which is kind of almost exactly like it with one major distinction. It is no longer size-based. It's only time-based. And the downside of having it size-based was, say you wanted to keep everything in Transport Dumpster for 2 weeks, but you limited it to, say, 18 megabytes, which was our out-of-box default in 2010. So you could have 18 megabytes worth of stuff in there that maybe planned to stay, but then a 10 megabyte message comes in and kicks out a bunch of stuff because you're over the size limit. So you actually could have reduced your redundancy because of that size limit that we had on there. There is no more size limit. Now it's just a time limit. So a safety net retention could be 2 days, 3 days, 7 days, 14 days. The key here is that if your safety net retention period is greater than or equal to your replay lag time, then you don't necessarily need to replay your log files at all. When you're activating a lag copy, you can just mount it as is with just a few required log files to mount it, and all of the missing data that would have come from replaying the log files will automatically come from Safety Net instead, from the transport queue, and that will populate the data with that information as well. And that makes the activation a lot easier and a lot faster. You can still do the old school way if you need to only activate up to a certain point, so you can still do the log surgery if you need to. But if all you want to do is just bring the database up to date and have it be a viable copy, then all you need to do is mount it, and it will automatically request resubmission for all of its missing messages from the Safety Net feature. All right. So that was the storage area. Now let's talk about some of the high availability features that we have. And again, thinking about some of the challenges that we have. Well, it's not really a challenge in Exchange 2010, but certainly in Exchange 2013, the challenge if you take the model that we use for database high availability in Exchange 2010, that model works great for 2010, not so well for 2013. The reason is in 2010, we're really only focused on database and content index health. That's what we're looking at. And that's fine to look at that from a DAG perspective. But because of the architectural differences in 2013, importantly, the fact that all access to a mailbox now goes through the protocol stack on the mailbox server. Just looking at the health and status of the database and content index is not good enough for 2013. The high availability criteria that we used was insufficient to determine whether or not something was highly available in 2013. Best copy selection, same problem there. The algorithm that we used in 2010 simply won't work for 2013 because of the architectural differences. And then, as we've done, particularly for those of you who've gone from 2003 to 2007 to 2010 and now to 2013, you've seen hopefully HA, in particular the setup and configuration, has gotten easier and smoother, and you have to do fewer and fewer things. We're continuing that around some DAG networking stuff that we didn't quite finish up in 2010, and now we've polished up and got finished in 2013. So let's talk about the HA innovations. So we're going to talk about managed availability a little bit, not too much because we had a whole session on it earlier today, which if you didn't get to see, there is a recording available. Then we're going to talk about the changes to best copy selection. In fact, not just a change in the algorithm, a change in its name as well. And then we'll talk about some of the automatic DAG networking things that we're doing. So managed availability, what is that? Managed availability is internal monitoring and recovery-oriented features that extend the high availability from well beyond the database and the content index to basically every other piece of Exchange. So it's HA permeating all the protocols, permeating all the dependencies, permeating all the components and features and every aspect of Exchange. Okay? It's in there because, remember, access to anybody's mailbox is always driven by everything that's going on in the mailbox server. Okay? Whatever mailbox server hosts the active copy of their database, that's where everything is happening. Sure, they go through CAS, but CAS is just a lightweight protocol proxy. It's just taking the transmission and forwarding it on to mailbox, and mailbox is doing all the work. So just looking at database health or just looking at content index health, that's not good enough to tell you if the server is a good candidate to fail over databases to. You have to look at everything, the protocols, the dependencies, the overall health of the server as well. And so managed availability, that was introduced there to basically cover failures and other scenarios outside of the bailiwick of the DAG and outside of Active Manager, so that we had recovery-oriented features that covered things other than the databases. So managed availability is really an internal framework. Okay, so you don't have to worry about it or do any heavy lifting at all. It was a framework recreated inside of Exchange, and it's a framework that all the component teams in Exchange have to write against. They have to create their own managed availability components in this framework. So the Outlook Web App team had to come up with a bunch of probes to figure out how to test Outlook Web App to make sure it was okay. They had to figure out a bunch of monitors to figure out where their thresholds would be to determine that level of okayness, if you will. And they had to come up with all the different responders that give them a pre-programmed sequence set of steps to correct problems that affect their components. So again, in the case of Outlook Web App, that might mean restarting an application worker pool, it might mean restarting IIS, it might mean failing over a server, and so forth. Okay? That's where managed availability comes in. Managed availability has one more side effect, though. It completely changes the best copy selection algorithm that we introduced in Exchange 2010. In fact, we don't call it best copy selection anymore. Now we call it best copy and server selection. So in the case of managed availability, it now also has the ability to do failovers as well. So for instance, managed availability can detect that there is a server-wide protocol outage, in which case it will react to that by initiating a server failover. Or it might detect that there is a problem isolated to a single database, in which case it would just go ahead and initiate a single database failover as well. And then one of the other things that we did is we took the single copy alert, which was a script that periodically ran through the task scheduler and alerted administrator to when a replicated database was down to one copy. That's why we call it the single copy alert. And we've baked that into managed availability. So it's not a separate script anymore. It doesn't require the task scheduler. The task scheduler is no longer required for mailbox servers like it was in Exchange 2010. So that can be turned off if you want. And now the single copy alert will just work as part of the data protection health set as part of managed availability. So that got also easier and smoother for you as well. Now, I mentioned enhancements to the best copy selection algorithm. So we don't call it best copy selection because it's not enough just to find a good database copy to activate. You've got to find a healthy server to come on as well. So we call it best copy and server selection. Here's why things change. Remember, in Exchange 2010, when we were running the BCS, the best copy selection algorithm, we were largely just looking at 4 things: copy queue length, replay queue length, database status, and content index status. Just looking at just those 4 elements doesn't really tell us anything about the server. Doesn't tell us if the protocols are working, doesn't tell us if users are going to get access when we fail over. All it tells us is, hey, are your databases healthy? Are they up to date? Is your index healthy? Is it up to date? That's all we know from that criteria. So using just that, it's not good enough for 2013. Because we have to look at everything on the server now. And actually, we don't look just at everything on the server. We also now take the extra step of examining the source as well, where that failure occurred. Now, I'll show you what I mean by that. So BCS, it's still an active manager algorithm. It's still run every time there's a failover or a target list switchover. The replication health still uses those same 4 criteria, so all that stuff still applies to the database. But now we've imposed additional constraints and additional criteria so that the algorithm has to look at everything going on the system. So what do I mean by that? Well, there's 4 new constraints that we've added to the best copy and server selection algorithm. And the first one is all healthy. So what that means is, in addition to finding a server that has a viable database on it, it's got a good database, got a good content index, all healthy means we're looking for a server whose managed availability health sets are all green. There's nothing wrong with any of them whatsoever. Everything is healthy, 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 and it's the best possible place to fail over to. If we can't find a server that meets that criteria, then we will look for what we call up to normal healthy. Now, we haven't talked about it yet, but the health sets in managed availability, they have a priority associated with them. Some health sets, as you might imagine, have higher priorities than others. So, for instance, the Active Directory health set, that's super high priority. If Active Directory is not healthy or we can't reach it, Exchange comes falling down. We need Active Directory constantly. But something like IMAP, we could probably live without IMAP for a little while. So IMAP has quite a little bit lower priority than something like Active Directory, or even a more commonly used protocol like Outlook Web App or Exchange Web Services. So there's some things we can sort of limp along in a bad state, but there's other things where they're super high priority and we can't operate without them. So we're looking at all the health sets that have a medium or higher priority, and we're looking to see if they're all healthy. Okay, and if they are, that would be the candidate that we would fail over to. If they're not, then we'll look for what we call all better than source. So again, this is a different approach. In 2010, we didn't consider the source. In 2013, we do. So what that means is we look at the nature of the failure on the source, and we try to find a target that is better. So if the failure was Outlook Web App died on the source, we need to find a target that has Outlook Web App in a healthy condition. Otherwise, we won't fail over to it. And then the last criteria is same as source. Okay, we've evaluated all the health sets, and the health sets for the server we want to fail over to are largely in the same state as the server on which the failure occurred. We will actually try to fail over to that server as well. Might not make things better. Things might end up being exactly the same way they are, but we try anyway in hopes that they'll be better. But the big constraint is because they have to be at least in the same condition as the source, things will never ever be made worse as a result of failover. This algorithm prevents that from happening. So things might not get better. They might end up in the same situation, but it still is the system trying to sort that out and trying to make things better. But things will never ever be made worse as a result of a failover operation because of these constraints that are imposed. All right, there are a couple changes to the best copy and server selection that we had in CU1. It's really the fact that we're now having the primary active manager track both the number of active databases per server and the maximum active databases parameter if that is configured. We didn't track that in 2010, and that was kind of a bummer because it meant that we could get pretty far in the failover process. We could actually have picked the database and picked the server, and when we go to try to mount it, that's when we get a message saying, sorry, too many databases, can't mount it, go try another server. And so we would have to rerun the whole process again. Now, because we're tracking that ahead of time, any servers that are already at their limit, we don't even factor in. We know we can't mount on them, so we keep better tracking of that, and as a result, we're not thrashing that failover process. And in fact, failover in particular is pretty much twice as fast in Exchange 2013 as it was in 2010. So I know we talk about 30-second failovers in 2010. The reality is, in our own dog food environments, we were seeing failovers happening in about 20 seconds with Exchange 2010. Now in our dog food environments, we see failovers happening with 2013 in about 10 seconds. So failovers twice as fast in Exchange 2013 now, even though we're doing all this extra work. Now, the last area of the HA portion is the DAG network configs. And honestly, it's not a huge challenge. It wasn't something where customers were complaining or we were struggling with this in the service. This is more really fit and finish type stuff where Exchange would really like to abstract away some of the more mundane configuration features like clustering, like we did with Exchange 2010. You really don't touch the cluster anymore. Exchange installs clustering and configures it for you. We wanted to do the same thing with DAG networking. We didn't quite achieve that with 2010, but we did a bunch of work and we were able to get automatic configuration for DAG networks out of the box. So what that means is the default is automatic. By default, your DAG networks are basically read-only, if you will. You won't be able to see any information in the Exchange Admin Center. And if you run PowerShell, all you'll be able to do is view the configuration. You won't be able to manipulate it until you change your DAG networks over to manual control. Now, you can do that through the shell. But let me show you in a screenshot where you can do that from. So if you haven't seen it again, this is the Exchange Admin Center, and this is what a DAG looks like here. And you can see over here on the right, I've got my networks listed. In fact, give me just a sec here. I want to start zoom it so I can zoom in for you here. Oops. Okay, so you can see over here to the right, it lists the networks that I have, but these aren't clickable links. I can't do anything with it. So instead, what I have to do is I have to click up here, this little edit thing, and that takes me into the DAG properties, and then there's this circle checkbox that you want here that says configure database availability groups manually. And so when I go in here and I check this box and I click save, now you can see over here things appeared. Now I can do things like remove the network, I can view details, I can disable replication if I want to. Maybe it's a MAPI network and I don't want to use that for normal replication. So if I go in here and I do something like view details, now I can see all the information related to my DAG network. I can see, for instance, the name of it. I can see the subnets. I can see the interfaces, whether or not they're up and so forth. And I can enable and disable replication. But until you configure the DAG for manual network control, you won't be able to manipulate your networks at all. And generally, most of you won't need to manipulate them, but there may be some other operations that you'll end up having to do, like resubnetting a DAG or moving DAG numbers around and so forth. But generally, there shouldn't be too much stuff that you have to deal with your DAG networks. But just be aware, it's different now out of the box. Out of the box, it's sort of read-only, or what we call auto-config. The other thing that we'll do, and I can't show you on here because I have a single subnet DAG, but we will do one other cool thing for you. And that is, if you are deploying a multi-subnet DAG in Exchange 2013, we automatically collapse your DAG networks for you now. Okay, that was a manual process that you had to do in Exchange 2010. You don't need to do that anymore in 2013. We will collapse them for you. And that's important because there were a lot of customers forgetting to do that in 2010. And they would have both a MAPI and replication network, but if you don't collapse your networks, we'll only replicate over the MAPI network, and they would never get their replication network used. Now we solve that problem because it just happens for you by default out of the box. Yes, sir? Sorry, a little louder, please. What happens when you are using iSCSI network? So you'll have to do the same thing. There is that additional step if you've got iSCSI networks, or maybe you've got a dedicated backup network in there. You need to run the set DAG with the ignore network switch and tell it to ignore those networks. Yeah, that part we still can't do automatically because we don't know what networks you want us to ignore. Yeah, that would be nice. I'll take that feedback back. That's a good idea. Okay. All right. We're almost done. One more section. Let's talk about site resilience now. Okay, so how many of you have more than one data center in which you've deployed Exchange? So you've got Exchange in multiple data centers. Okay, how many of you have 2? Okay, 3? 4? Anybody with more than 4 data centers with Exchange? All right, cool. All right, so this actually, the site resilience portion, I love all this stuff, but the site resilience portion to me ends up being my favorite part because we've literally taken all of the challenges that we had around site resilience in Exchange 2010, and we've made it literally the opposite of what it is in 2010. So 2013 is literally the polar opposite of 2010. There are scenarios, particularly for those of you with just 2 data centers, where you may have a similar configuration or a similar paradigm with 2013. But from a general site resilience perspective, we've done a number of significant things that really changes 2013 quite drastically over 2010. So some of the challenges that we had with 2010, well, it's operationally complex. How many of you have a DAG in 2010 extended to multiple data centers? Right? And how many of you have done a data center switchover in that environment? Yeah. And how many of you enjoyed it? 1. And how many of you were able to do it in less than a half hour? Okay, your first time. Exactly, yeah. They are operationally complex. Even if you've done them several times, they are operationally complex because of all the moving parts that you have in 2010, all the different groups that have to get involved, your networking folks, maybe if you're using your telephony folks, your DNS folks certainly have to get involved, and it just becomes kind of a mess, and something that can take a long time. And of course, because it's a switchover, it's a manual process, and the whole time that you're doing it, you're down. No one's getting into email during that time. So that's one huge challenge that we have. Another challenge is mailbox and client access in Exchange 2010. They're pretty much tied together. You can't deploy either in an Active Directory site without the other one. You cannot recover one without the other one. So even if your DAG is fine, if you lose the majority of your CAS array, you're still recovering your DAG in another data center, which is a huge bummer. And the biggest challenge that we have is the namespace, or the URL you hand out to your users. That's a single point of failure. Arguably the biggest single point of failure in the entire solution. Why? Because it's where users are told to go. Okay? And users are only typically given that one place to go. And if that one place to go is down, users are down. They're not getting in. It's a huge, huge single point of failure. Now, the innovations that we have are based on, in large part, some of the key characteristics around the architectural changes and some client connectivity changes that we've made. So we haven't talked about it in this session. Perhaps for those of you who were at Nathan's session on Client Access Server, you heard about it. But there was a change that we made around Outlook client connectivity. So in Exchange 2010, there were 2 ways an Outlook client could connect to an Exchange server. They could use Outlook Anywhere, or RPC over HTTP, Outlook Anywhere, or they could use just RPC over TCP, which is what most internally domain joined clients would use. We no longer allow connectivity over RPC over TCP. Okay, we're still using MAPI. So some people have mistakenly misinterpreted that as, oh, we don't use MAPI anymore. We do. We now only allow connectivity for an Outlook client into Exchange 2013 over Outlook Anywhere only, RPC over HTTP. So what that means basically is Outlook, like OA and ActiveSync and web services and PowerShell, is an HTTP client now. Okay? Keep that in mind. Some other things. there's a new approach for the namespaces, okay? And that is leveraging the ability to create multiple A records in DNS that point to multiple IP addresses. This is not new behavior. This has been going on the internet for well over a decade. And all modern operating systems and all modern web browsers exhibit this behavior. And in fact, you can witness this behavior yourself. Fire up NSLookup, type in www.bing.com, and see the resolution that you get. If you have IPv6 enabled, you'll get a couple IPv6 addresses, and then you'll get some v4 addresses in a round-robin order that is dictated by your server. And in fact, if you do an immediate query after that, you'll see those IP4 addresses change their order in which they're delivered to you. And all of the modern operating systems and modern HTTP clients, they have the ability to have their own caches with these IP addresses in them. And they have their own failover ability. If they cannot make a TCP connection to the first address in the list, they wait 20 seconds and fail over to the next address in the list. They can't do that there, they'll fail over to the next one and the next one until they've exhausted all of the IPs. Typically no more than 8, but it depends on the browser and the operating system. So in other words, the client now has the ability to have built-in failover for the same name. The name doesn't change, just the IP address does. Some of the other characteristics is this is an HTTP failover capability, which means Outlook, now being an HTTP client, also will exhibit this behavior. So this will work for all your clients, any web browser you use, the Outlook client that you use, even Outlook 2010 and RPC over HTTP mode. Will also work for your ActiveSync devices. It'll work for your web service calls, anything that's HTTP based that's doing name resolution to find out where the namespace is. Now, clients will skip past any address that produces a hard TCP failure. So it has to be a hard failure, not a gray failure, which would be I can make a TCP connection but not an HTTP connection. Can't do anything for that. But if we can't make a TCP connection, the client will automatically fail over. You have that behavior built in. And admins can, at any time if they want to, if they know they've got one of the IPs that's going to be in a failed state for a while, they can go in and remove it from DNS, and then it won't get handed out to clients at all, and that'll save time that way. And what that really means, though, is that the namespace is no longer a single point of failure. In fact, it's just the opposite. The namespace is now being used to provide redundancy for the client. And there's no dealing with DNS latency because you don't necessarily need to do a data center switchover. Now, in Europe, DNS latency is not such a big deal, but there are some parts of the world where DNS latency is really bad. Could take a day or two before all the records get replicated around where they need to. So we solve all these problems by going down this route. So site resilience now is operationally simplified in 2013. And the mailbox and client access, they're recovery independent. Okay, if my DAG dies, I don't have to recover the CAS array. Everything is completely decoupled. And as I mentioned, the namespace is providing redundancy. So what do we mean by operationally simplified? Again, if you lost your CAS, the majority of them, your CAS array, your load balancer, the virtual IP in front of the load balancer, or your DAG, or the majority of your DAG, then you only need to recover what's failed. Or in some cases, depending on your configuration, don't do anything and the system can recover itself, as I'll show you in a moment. Now, because this is an automatic recovery, that takes all the pressure off the administrator too. Okay, because the system is going to self-recover, and any administrator will tell you that replacing a failed part that isn't affecting service is a lot less stress than trying to restore messaging service in a secondary data center. It's just a whole different level of stress. Basically, there is none with the failed equipment. So the admin just focuses on fixing the issue, not restoring service. That's a huge, huge change. What do we mean by the recovery is independent? Well, again, in Exchange 2010, they're tied together. And because of that, even if you only lost one, you had to recover the other. And that was always going to be a manual process for both of them. But in Exchange 2013, again, depending on your configuration, you might not have to recover them both. And recovery could come in the form of automatic failover, even at the data center level, which we can never give you at 2010. And then the namespace provides the redundancy, as I mentioned earlier. Clients are automatically getting multiple IP addresses because the administrator has configured multiple A records in DNS. And so the clients are automatically getting those IPs when they do those lookups. So that means the namespace has redundancy built in because the client now has more than one IP address it's able to try. Okay, and that IP address could be your primary data center and your secondary data center. And there's a new deployment scenario option as well. If you happen to have the luxury of having 3 locations, 2 of which you deploy Exchange into, and the third pretty much just needs to be isolated from network failures that affect the other 2, then you can do something like take your witness server and put it in a third location, thereby achieving automatic failover for your DAG, even in response to a data center level event. So data center failovers for the DAG are possible with 3 locations in Exchange 2013. I do want to be super clear about one thing, though. We are not saying go get a third location so you can do this. Okay, the costs do not justify it. Okay, if you have 3 locations or more, you now have this new option available to you. But if you don't have 3 locations, if you just have 2 locations, then you might be doing the original 2010 paradigm, which is still better, is still a better experience than what you got with 2010 in 2013. So let's talk about some of these scenarios here. Let me give you some failover examples. So let's start with a simple one. We just have a 2 data center topology. I've got my primary data centers in Redmond. My secondary data center is in Portland. And we're using a single worldwide namespace. So mail.contoso.com is the namespace that we're handing out to users. That's where they go to get their email. And we've got 2 A records in DNS, one that points to 192.168 and one that points to 10.0.1. And so the way it works is a client will resolve mail.contoso.com, and they'll get back both IP addresses. Again, it'll be in a round-robin fashion, so they might try the Redmond data center first, or they might try the Portland data center first. Doesn't really matter. All that matters is they have a way to get in. Now, let's say we lose maybe the whole Portland data or the Redmond data center, or we lost the load balancer, or for whatever reason, nothing's answering on that IP. The clients are just going to automatically fail over. Why? Because they've got that other 10.0.1 address to try, and that's what they'll do to reestablish connectivity. So the administrator doesn't need to intervene. They really don't need to do anything other than investigate the problem in Redmond and then fix that problem and reestablish service. But if it looks like, something really catastrophic happened, Redmond is a smoking hole and it's not coming back, the administrator could change DNS, remove that failed VIP out of there, the 192 address, and just leave the 10.0 address in there. Whether or not you actually change DNS is going to be up to you. You'll have awareness as to how long the outage is going to be. If it's going to be a short time, I wouldn't mess with DNS. I would just let clients get the bad address and they'll fail over automatically. It'll just be like a 21-second delay for them. But if it's going to be a few days, then you might want to save the time and remove the failed one out of DNS, in which case DNS will then only hand out the good IP address, and that's all clients will try to use. So you've got some flexibility and some choice there. Okay, that's the front end. Now let's look at the back end. And let's look at first the 3 data center scenario. And again, when we say 3 data centers, we mean 2 data centers with Exchange, in this case Redmond and Portland, and then a third data center that just needs to be isolated from network failures that affect the other 2 data centers. Now, in my case, I put my witness server in a data center that's in Paris. And this is actually a trick from the service. We always have our witness servers on a different continent from the DAG members. And we do that because that is the only way to truly isolate them from network failures. I don't know how many of you have ever seen that mapping of the underground cables of the internet. You can see where the fiber runs along the ocean floor, around all the continents and whatnot. There's actually some parts of the world where there's just the one big cable coming in, and if that gets severed, and they get severed all the time, but if that gets severed, that's going to take out a large region. It could take out Australia, New Zealand, a large majority of Asia with it, and so forth, just by severing one cable. So the only way we can really realistically isolate the witness server from these types of failures is to literally have it on a separate continent. So in this case, the primary and secondary are in North America, and the witness server is over here in Europe. The other reason I chose Paris is I also like to visit my witness server for 2 weeks in the summer every year, so Paris is a great place to do that. Okay, so what's the scenario looks like? We lose our primary data center, but unlike Exchange 2010, in this configuration, I don't need to do anything because that failure didn't affect the other 2 sites, which means as long as I had my witness server up and running, which it is, These other servers can try to reach out. One of them will lock it, regain majority, keep quorum up and running, and the solution will just stay up and running. And you get a data center failover for your DAG, something that customers had been asking us quite vigorously in Exchange 2010, but we couldn't deliver it in 2010 because we had to make all these changes in 2013, in particular the decoupling of CAS and mailbox to make this happen. But there were a lot of other changes that went into it. The load balancing changes, the re-architecture, the namespace simplification, all of those things had to be done in 2013 to make this a reality. So you cannot still do this in 2010. This is 2013 only. And again, this configuration option is only there if you have a third location. If you don't have a third location, it's not worth the money to go and get one just so you can get this automatic failover. One second. Let me just run through a couple other scenarios and then we'll take questions. So let's just say you don't have 3 data centers. You're in the 2 data center topology. So you followed our best practice. You've got your witness server in the primary data center. So same scenario. You lose your primary data center, just as it was in 2010, because you've lost the majority of voters. These 2 in the alternate data center are going to lose quorum, and they're also going to terminate. So now you need to do a data center switchover. However, the data center switchover that you need to do is really just focused on the DAG at this point. So to do that, really it's just 3 steps. Okay, it's not that long, lengthy set of steps that you had to deal with in Exchange 2010. Doesn't involve changing DNS or anything like that. It's pretty much just running stop DAG, so you can mark the failed servers as down, stopping the cluster service on 3 and 4 over here, and then running restore DAG to shrink the underlying cluster, regain quorum, and bring the survivors up and running with an alternate witness server. And again, those 3 steps is something that could be handled in a script, and it will just take literally a few moments to run. And assuming you don't have your databases activation blocked, they'll automatically mount on 3 and 4 and services restored. You didn't have to touch CAS, you didn't have to mess with DNS. All you had to do was run a couple commands and your DAG is back up and running again. All right. The last thing I want to talk about is just a couple cool things that are coming in CU2, and then we'll have time for some questions. So one thing that's coming, there's a new service that's going to be installed on your mailbox servers. This is not a big deal or anything really to blog about or write home about. It's the DAG management service. What we've realized is that the Microsoft Exchange replication service was getting a little bit too big in terms of its functionality for our comfort. So we have started the process of carving out some of that functionality and putting it into separate services and separate processes. So our first run at that will be to take some of the monitoring functionality that the replication service was doing, and that is what's going to be the new DAG management service in CU1. So you'll see that appear, CU2, excuse me, once you deploy CU2 mailbox servers. We probably will be moving other functionality over to it later on in the future, but for now, all it's really doing is some of the DAG monitoring work. So this is just step 1. Again, it's a really minor architectural change, but it is new and different for DAG, so I thought I'd mention it. What else are we doing? Well, this might be a benefit for those of you who only have 2 locations, but you happen to be Azure subscribers. Now, a couple of things I want to point out. One is that, sorry about that, the DAG management service, that's a done deal. That code is checked in, it's in the builds, it's there, it's not going away. The Azure stuff, that is not a code change. This is testing and validation that Exchange is doing across Microsoft right now. So this may or may not be in CU2. We are trying to get it into CU2, but if CU2 releases before we're done testing, then most likely we will release support for this out of band, for instance, in between CU2 and CU3, because it doesn't require a code change. We just need to test and validate. Now, just like it's not worth it to go get a third data center, it's not worth it to buy an Azure subscription just so you can have another place to put your witness server. It's not worth it. If, however, you are already an Azure subscriber, and you don't mind doing things like taking your Active Directory and extending it to Azure by deploying a DC from your environment in Azure, and then creating a file server in Azure so that you've got local permissions and local authentication, If you don't mind taking your on-premises Active Directory and extending it to the cloud, then this should make a great scenario for you in terms of getting that third location for your witness. But again, you might not be 100% comfortable with that, but it does require extending AD into the cloud and having both a DC VM in Azure and a file server VM in Azure with a persistent VPN connection between Azure VPN and your own internal organization. If you don't have that or you can't meet those requirements, you can't do any of this stuff. All right. And then the last thing that we talked about coming in CU2 is we are going back to 100 databases per server support with the Enterprise Edition. CU1 and RTM are limited with 50, and now we are, after doing a bunch of work and extra testing and validation, we feel very comfortable in moving it back to 100 databases per server. All right. Boop, there goes the bird. All right, so with that, I'm happy to take, well, I see 000 on the clock, and I realize I am right now the only thing standing in between you and alcohol. And I'm going to be at the Tech Expo after this, so why don't I release you all, and you can go get your drink on, and then come by the Exchange area of the office booth, where I'm happy to answer all your questions and hand out Exchange architecture posters as well.